Hello, students. Myself, Mrs. Mansi Agarwal, Assistant Professor, ABES Engineering College, Ghaziabad. Today, we will be discussing our next topic of data structures, that is counting sort algorithm. Counting sort algorithm is a non-comparison based linear sorting algorithm. It works efficiently for the small range of inputs as compared to the number of elements to be stored. The main idea is to count the frequency of each distinct element in the input array and use this information to place the elements at their appropriate positions. So, in order to have a better understanding of how the counting sort algorithm works, let us take an example wherein we have several elements ranging from 0 to 9 and they are stored in unsorted manner. Suppose we have 7, 0, 8, 9, 3, 2, 7, 5, 3, 9, 8, 7, 1, 4, and 5. And suppose the indexes of this array starts from 0 till maybe 14. So that means we have a total of 15 elements stored inside this array. Now, first of all, we have to understand that the counting sort works on the input in which the range of values that we have it has to be very, very less than the number of elements. It has to be less than the number of elements that we have that we want to sort. So like in this case, we can see that the values are ranging from 0 to 9, but the number of elements are 15. There is not much difference in this example, but when we use the counting sort algorithm in the real life situation, then the range of the values is less, while the number of elements may go up to thousands of lakhs. Now, suppose this input array is represented by A. The counting sort works by first of all making a counting array which is used to store the frequency of the input values. So suppose this is a counting array represented by C. Suppose the elements are stored inside this counting array on the indices 0 to 9. Let me just quickly draw this counting array. So I have made this counting array from 0 to 9 as the values that we are taking. The values that we are taking are one digit values and they can be from 0 to 9 only. So now, first of all, we have to initialize this counting array by 0. So let me just write 0 in each of the block of this array. Now I have to iterate through all the elements of the input array. And whenever I'll get a value, I will increment the value of that particular index inside the counting array. Suppose I have got 7. So I will increment this value by 1. Right? This indicates that the number of times 7 occurring in the input array is 1. Then I have got 0. So I will increment this value by 1. Again, I have got 8. I will increment this value by 1. Then I get 9. I will increment this by 1. Then 3. And this 0 will become 1. Then 2. But 2, this will become 1. Then I have 7. Again, this value will be incremented to 2. Then 5, this will be incremented to 1. Then for 3, this will be incremented to 2. Then 9, this will be incremented to 2. And for 8, this will be incremented to 2. Then for 7, this will be incremented to 3. Then again, I have got 1. So this will be incremented to 1. Then 4, this will be incremented to 1. And then 5, this will be incremented to 2. Now, let us reconstruct this counting array so as to store the cumulative frequency. So let me just reconstruct this array, and the elements will be stored at the indexes 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So the number of elements which are less than equals to 0 are 1. Number of elements less than equals to 1 are 2. Number of elements less than equals to 2 are 3. Number of elements less than equals to 3 are 5. Number of elements less than equals to 4 are 6. And in this way, we have to reconstruct this counting array. So for 7, this value will be 10. Six. This will be 8. Then this will also be 8. This will become 11. This will be 13. And this will be 15. So this represents the frequency array, which gives us the value which tells that how many number of elements are less than or equal to a particular element. Like if you talk about 9, so there are 15 elements which are less than or equal to 9 in the input array. Now what we have to do is we have to again construct an array which will be called as the output array. Suppose the output array is here represented by B, right? And definitely the number of elements in the output array will be same. Number of elements will be same as that of the input array. So let me just create this array having indexes from 0 to 14. 9, 10, 11, 12, 13, and 14. So these are the total number of elements that what we have to do, we have to start checking from the last element of the input array. What is the last element? The last element is 5. Now we will go on the index that is having the same value, index number 5. And then we will look at the value stored inside the counting array. The value stored inside the counting array is 8. That means the number of elements less than or equal to 5 are 8. So that means the 5 element, the last 5 element will be stored at the index 7 in the output array. In the output array. Let us now take the next value, which is 4. The next value is 4. Now we have to go on again on the counting array, and in the counting array we have to look at the value which is stored at index 4. The value stored at index 4 is 6. That means there are total 6 elements which are less than or equal to 4. So that means 4 will have index 5. Index 5 in the output array. In the similar way, we will check for value 1. For value 1, we have 2 in the counting array. That means there are only 2 numbers which are less than or equal to 1 in the array. So that means this 1 will be stored at the index 2 minus 1, that is 1. The next value that we have to take is 7. Right. the next value that we have to take is 7. 7, for 7, we have the value stored in the counting array is as 11. So the number of elements which are less than 7, less than equals to 7 are 11. So that means this will be stored at index 10. Right? In this way, we will keep on filling the values. Now, there is one more thing that we have to remember here is that suppose if I'm talking about 7, 7 has got index 10 because the number of elements that are less than or equal to 7 were 11. So that means it will hold from 10th index backwards, right? So whenever we will get 7 again, it will be stored on the index just prior to where it has been stored right now. So what we are going to do is we are going to decrement this value by 1. Whenever we are storing a number, then at the same time, we will keep on decrementing this value by 1. So like this value will be decremented so that whenever we will get the same value again, it will be stored on the index just prior to the previous index, right? So we have just now stored 7. Now let us see for 8. For 8, the value stored is 13. So it will be stored on index 12 here. And we will decrement this by 12. Then we have value 9. 9 is having index 15. So it will be stored, the value is 15. So it will be stored on index 14. And this will be reduced by 1. Then we have 3. For 3, here we have 5. So this will be stored on index 4. And this will be decremented by 1. Then we have 5. Now see for 5. For 5, the value is decremented to 7. So this time the index that we will get is 6, right? So this will be stored on index number 6. Value 5 will be stored on index number 6. And this will be decremented to 6. The next element is 7. For 7, we have 10. That means it will be stored on 9. And this value will be reduced to 9 for further use. Then we have 2. For 2, we have value 3. So this will be stored at index 2. And this value will become 2. Then we have value 3. For 3, we have 4. The value is 4. This will be incremented and it will be stored at index 3. Right? The next value that we have is 9. So for 9, we have value 14. So this will be stored at index number 13. Then we have 8. For 8, we have value 12. So this will be stored at index number 11. Then we have 0. For 0, we have value 1. So this will be stored at index number 0. Then we have 7. For 7, we have value 9. So this will be stored at index number 8. Right? So this is how we have got the sorted values. Right? Now let us discuss the algorithm of this technique. Now, let us suppose the algorithm can be named by counting, sort. It will have 3 parameters: the array, number of elements, and k. That is the distinct values, the range of the values that we are having. Okay? So let us just begin this algorithm. Now, in order to begin this algorithm, first of all, we have to take one array with the name C and we have to initialize it with 0. And as we have seen, the counting array was having elements from 0 to 9. So we can say that I will start from 0 till k, till k. And here what we have to do is we have to assign ci to 0. We have to assign ci to 0. The next task was to count the number of elements, the frequency of each element. And in order to do this, we have to traverse to the input array, which was stored from 0 to n minus 1. From 0 to n minus 1, what we have to do? We have to check the element ai, right? And making it as the index of the counting sort, of the counting array. We have to increment this value. We have to increment this value, right? So the index number ai in the counting array will be incremented by 1 whenever we will get any element in ai, right? So if we are getting 7, then the 7th index will be incremented to 1. Then if again we will get 7 in the input array, then the index 7 will become 2, right? Now, the next task is to convert it into a frequency array. For this, we will start from the second index. Second index to the last index. The second index to the last index. So this will become 1 to k. Now what do we have to do? We have to keep on adding up the previous element in the current element. So ci will become ci plus ci minus 1, right? Now, as we have created the counting array, the next task is to traverse the input array from the last element, right? And why we have traversed the input array from the last element? Because we wanted to keep the elements stable, right? Keep the elements stable. As you can see that this 5, this 5, this 5, which is stored here, we have stored it at index 7 first, right? So the 5, which is getting a later position, will be stored at the later position only in the final array. And this 5, which is coming earlier, will be stored at a prior position in the final array. So this is how we are maintaining the property of the input being stable, right? So here we will start the value of I from n minus 1 down to 0. And what we have to do? We have to take ai. We have to make this ai as the index of C. That means we have to look this element as the index of C. And then after making it at index C, then the value, whatever the value we were getting, we have to decrement it by 1, as here we are storing the values from 0. And then this value will become the index of final answer, right? And this will store the value a of I. This will store the value a of I. This is how we will get the final answer. And at last, we will return this b. Right. Now, let us now analyze this algorithm. If we see that the first loop will work for k plus 1 times, the second will work for n times, the third loop again will work for k times, and the last loop will work for n times. So as you can see that here, the total number of iterations that are taking place are 2 n plus 2k plus 1, right? So here, as we know that k is very small with respect to n, so the total time complexity of counting sort algorithm can be represented by theta of n, right? And when we talk about the space complexity, of this algorithm, as we can see that we have taken two additional arrays. One is C and one is B. And we have also taken another variable I. But we know that the number of elements in C will be very, very small as compared to the number of elements in B, as the value of K is very much smaller than N. So we can ignore this K, and the total time, as the total time complexity was theta n, the space complexity will also become theta of n. The references taken for making this video includes Tenenbaum, data structures using C, Horowitz and Sahani's fundamentals of data structures Shom series, and Tareja's data structures using C. Thank you.